Say after we have rolled the dice for the first time, we want to roll the dice for a second time and calculate the probabilities of rolling a 4 and not rolling a 4 for these events. So just to recap, this is the first event, or the first roll of the dice, and these are the outcomes for the second event, or the second roll of the dice, and we label this event. The outcomes of the first event have no effect on the outcomes of the second event, so these two events are described as being independent of each other. Say we have rolled a 4 in the first event. We then create a second event by rolling the dice again and try and calculate the probability of rolling a 4 or not rolling a 4. And again, using our two equations, we can calculate these probabilities as being 1 over 6 and 5 over 6 respectively. And we do exactly the same thing for the probability tree for the first event where we have not rolled a 4. And using our equations, we again find the probabilities are 1 over 6 for rolling a 4 in the second event and 5 over 6 for not rolling the 4 in the second event. And there we have it, the individual probabilities of two events, rolling the dice for the first time and then rolling the dice the second time. Creating probability trees is the hard part. Now we'll be asked to do some simple calculations. Say we were asked to calculate the probability of the following events happening: rolling a 4 on the first roll and rolling a 4 on the second roll, rolling a 4 in the first roll and not rolling a 4 on the second roll, not rolling a 4 on the first roll and rolling a 4 on the second roll, and finally not rolling a 4 on the first roll and not rolling a 4 on the second roll. As mentioned earlier, the outcomes of the first roll and the outcomes of the second roll are independent of each other. So each roll of the dice is referred to as an independent event. And because the events are independent, we use the AND rule. And because we are using the AND rule, we have to multiply the probabilities together. Look at our first task. Here we've been asked to calculate the probabilities of rolling a 4 on the first roll and rolling a 4 on the second roll. And because the events are independent, we have to use the AND rule, and because we are using the AND rule, we have to multiply these probabilities together. And this gives us 1/6 multiplied by 1/6 equals 1 over 36. So the probability of rolling a 4 in the first roll and rolling a 4 in the second roll is 1 over 36. In our second task, we have been asked to calculate the probabilities of rolling a 4 on the first roll and not rolling a 4 on the second roll. This gives us the probabilities of 1 over 6 multiplied by 5 over 6, which is 5 over 36. So the probability of rolling a 4 in the first roll and not rolling a 4 in the second roll is 5 over 36. In our third task, we have been asked to calculate the probability of not rolling a 4 in the first roll and rolling a 4 in the second roll. This gives us a probability of 5 over 6 multiplied by 1 over 6, which equals 5 over 36. So the probability of not rolling a 4 in the first roll and rolling the 4 in the second roll is 5 over 36. And our final task is to calculate the probability of not rolling a 4 in the first roll and not rolling a 4 in the second roll. And this gives us a probability of 5 over 6 being multiplied by 5 over 6, which is equal to 25 over 36. So the probability of not rolling a 4 in the first roll and not rolling a 4 in the second roll is 25 over 36. You should note, like the individual branches in the probability trees, all these probabilities must add up to a value of 1. And there we have it. When calculating the probabilities of two or more independent events happening, we use the AND rule. We take each individual probability and multiply them together.